Hi, welcome to my channel. So today we are going to understand units and measurement. See students, when we are talking about a physical quantity or when we are going to study about physics, what we have to keep this in mind that what is physics? Physics is a science that based on the study of nature. So when you are studying nature, that means what? You need to be accurate and precise about what? About all the measurements that governs nature, right? So that is why we need to first understand what is a physical quantity. So let us understand what is physical quantity. Okay, so here I am going to write it on the board and I would advise you to please note it down everything and I write here in the board. Okay, so let's start. So here just see, I have written what is physical quantity. It is written all those quantities that can be measured directly or indirectly in terms of which the laws of physics can be expressed are called physical quantities. So that means any quantity that is measured directly or indirectly. So keep this in mind. So whatever we can measure, that's a physical quantity. So if for example, if I give you an example as length. Length is a physical quantity. You can measure length of a table, length of a person, that is we say height. If you talk about mass, that is also a physical quantity. Why? Because that can be measured, right? So now length, mass, you can also talk about temperature. That is also a physical quantity. Now understand, these are our physical quantities because this can be measured. Now you tell me, what do you think? You like to play football. How much do you like? Can you measure that? You love to have biryani. How much do you love? Can you measure that? No, we cannot measure that, right? So things that we cannot measure with any value, those are not physical quantities. Is that clear? Now coming to the next part, so when there is a physical quantity, what does that mean? That means we can measure that, right? That means we can measure that. For example, length, mass, temperature, these are physical quantities. So many are out there. Force, these are all physical quantities. We can measure that. So we have understood this one. Now we have to understand physical quantities are of two types. What are the two types of physical quantity? First one is the fundamental physical quantity. Fundamental physical quantity. Just see, when I am saying fundamental, what does it mean? Fundamental? Fundamental means that it is basic. That is, it is basic. So fundamental physical quantity, you have to keep this in mind. Fundamental physical quantity means it is independent. What does that mean? That means it is independent of any other physical quantity. And next what we have, derived physical quantities. Next what we have, derived physical quantities. Now you can understand from the very word derived physical quantities. So derived physical quantity means anything that is derived. Now you tell me, fundamental physical quantities are independent physical quantities. They are independent of any other physical quantity. I'm going to give you the example, don't worry. And what is derived physical quantity? Derived physical quantity is these are derived from fundamental physical quantity. Okay, these are derived from fundamental physical quantity. So let me give an example. If I give you an example, it will be very clear to you. Now tell me, if we want to measure the length, for example, I'm just writing over here, if you want to measure the length, what do you measure? Which unit do you are going to use? Like meter, centimeter, like this? For example, if you are measuring the length of a table, what unit you are going to use? Someone can say I'm going to use meter, someone can say I'm going to use centimeter, someone will say I'm going to use feet. That's up to you. I'll come to that unit system later. Now first of all, you understand, so fundamental physical quantities. Now when I'm talking about derived physical quantity, let me give you an example. If I'm talking about velocity, what is the unit you are going to use? You are going to use meter per second, right? You are going to use meter per second. So now let me give an example. So measuring length, when you are measuring length, you are using meter, right? Only meter. But when you are measuring velocity, what is velocity? Velocity is displacement by time. Velocity is what? Displacement by time. What does that mean? That means unit of velocity displacement you are going to measure in meter and time you are going to measure in second. So ultimately unit of velocity will be coming in meter per second. Now please focus here. If you are talking about velocity, you have to express something about displacement as well as time. So that means in order to express velocity, you need two different quantities, right? What are these? Displacement, time. But in order to express length, what physical quantity you need? Only one, length. Height of a person. Suppose if I am talking about my height. What is my height? My height, I can say 1.77 meter. Okay. So when I am saying 1.77 meter, what do you think? Do I need to express mass? Do I need to express temperature? Do I need to express any other quantities? No. Only height, that is only the length. But if I'm talking about velocity, if I'm talking about force, if I'm talking about momentum, what I have to use more quantities, right? So that means you can understand derived physical quantities, these are derived from fundamental physical quantity. So velocity, that is displacement by time, that is derived from fundamental physical quantity. If you are asking me, sir, what will be about force? What is force? Force equal to mass into acceleration, right? Mass into acceleration. So that means mass is a physical quantity, acceleration is also a physical quantity, right? So acceleration, in order to find out acceleration, you also need to find out displacement by second square. If you remember, I'm going to discuss all these things, don't worry. So is this part clear to you all? What is fundamental physical quantity and what is derived physical quantity? Okay. Now we are going to the next part, that is what are units and how we are using the units to find out the perfect measurement. Coming to the measuring process. So we have understood what is physical quantity. Next we have to understand how to measure. Now when I am going for measurement, process of measuring is like this. What is the process of measuring? What is process of measuring? See, process of measuring will be like this. Just understand, if I am talking about this is a quantity, and quantity will be is equal to, this is a physical quantity that will require two things, n and unit, u. So here n stands for numerical value, and u stands for a given unit, any specified standard unit. It stands for a specified standard unit. Q is equals to nu. That means a physical quantity needs a numerical value as well as another standard unit. So let me give an example. Suppose I am saying height of a person. So you tell me, height of a person is the measurement of length, right? So measurement of length. So what we say, height of a person is 1.77 meter. Now here 1.77, this is your numerical value. And what is m? M is your standard unit. So what is the standard unit over here? 1 meter. Standard unit over here is 1 meter. Suppose you have went to a shop and you went to the shop and asked for, like, you need to find out how many or how much cold drinks is there. You want to get some cold drinks for your house. What you are going to do? You are going to ask the shopkeeper, like, give me 5 bottles of cold drinks. So what is the quantity you are getting? You are getting quantity is Cold drinks, right? So what is the quantity of cold drinks that you are getting? 5 bottles. Now you tell me, which is your numerical value over here? 5 is your numerical value. And which is your standard unit? That is 1 bottle is your standard unit. Here I have written 5 bottles, that's 5 bottles, plural, standard unit. This is standard unit and this is what? Numerical value. This is numerical value. So is this clear? So that means this is how we measure physical quantities. Now, another important part that I have to say, physical quantities can be expressed like this. Also, we can also say physical quantities like this. N1U1 is equal to N2U2. N1U1 is equal to N2U2. That means a given physical quantity can be measured using different set of units. For example, if I say, suppose I have got a table, length of the table is, if I am telling length of a table, if I am writing 1 meter, right? And you are saying that, sir, it's not 1 meter, it's all right, but you are asking the carpenter to make 100 centimeter length table, right? So what do you think? 1 meter and 100 centimeter, these two are same quantity, right? But see, here I have expressed is in meter, that's why the numerical value is different, and here I have expressed in centimeter, that's why the numerical value is different. So that means this is what? N1, this is what? U1, this is what? N2, this is what? U2. Understood? So nothing, it's a very easy part. What is the easy part? Q is equals to N1 U1 is equals to N2 U2. That means a given quantity can be expressed in one set of units as well as other set of units. Now when we are talking about these units, there are several other system of units are there. So let us find out what are the different system of units are there. Okay, please note down this part. Now coming to the system of units. That means just now we have understood that to measure a physical quantity we require unit, that is a numerical value as well as a standard unit, right? So now we have to understand what are the different system of units. For example, if I say CGS unit, what I am saying, just understand CGS unit. CGS system of unit, what does that mean? That means you are measuring length in centimeter, mass in gram and time in second. So this is a system of units where you measure the length in centimeter. So C stands for centimeter. You measure mass in gram. G stands for gram. And time in second. A stands for second. So that means we are measuring all the physical quantities. If there is any involvement of length, mass, time, we are measuring these values. I am giving you in one example, then you will be able to understand. For example, in CGS system, if I am talking about velocity, velocity will be what? The centimeter per second. Got it? If I am saying acceleration, acceleration will be what? Centimeter per second square. I hope you all know the units of velocity and acceleration. Here displacement by time, here velocity by time. So that's why here displacement I have measured in what? Centimeter, and time is in second. Now if you are asking me, sir, what will be momentum? If you know the formula of momentum, what is momentum? Momentum is equals to mass into velocity. Momentum is mass into velocity. What is mass? Gram. What is velocity? Centimeter per second. So this will be gram centimeter per second. So this is why we are saying this is CGS system of units, where we are measuring length in centimeter, mass in gram, time in second. Okay. Now there are other system of units. For example, FPS system of unit, where length is measured in foot. F stands for foot. mass in pound and time in second. So that means you can understand F stands for foot, P stands for pound and A stands for second. So this is what FPS system of unit. Now if you're asking me, so then what is MKS system of units? So coming to MKS system of unit, MKS, that means mass in meter, then length in meter, mass in kg and time in second. This is MKS system of unit. Got it? Now these are the different system of units that I have understood. Now why do we require SI unit? Why do we require SI unit? Because there are some advantages of SI unit. Suppose you were studying in London, okay, and another child is studying in India, and when they are going to do any kind of research together, now in your country, if you are doing with MK system and the student who is studying in London, that is doing with FPS system, now what will happen? There will be a problem in the research. So that is why what we do, that is why we are going for a basic one system of units that is universal for the entire world. That is why we are using SI unit. So SI stands for International System of Units. SI stands for International System of Units. Now there are some advantages of SI. What are the advantages? I am going to come out for that. First, understand SI is a universal system of units. That means universal means it is accepted all over the world. It is accepted all over the world. This is the first thing. So in SI unit, length is measured in meter, mass in kg, time in second. Now you are going to say, sir, what is the difference between SI and MKS then? There is a difference. We'll come to that. There is a difference. So this is SI unit. First important part, what are the advantages? What are the advantages? First advantages, it is accepted universally. It is accepted universally. Second advantage, it's a rational system of units. It's a rational system of unit. I'm explaining that rational system of unit. Rational means what? Rational means one that makes sense, right? So this is a rational system of units. For example, in MK system, in order to express heat energy, we use calorie, right? But in SI unit, what we use? Joule. Now, the reason is that MK system, for heat energy using calorie, for kinetic energy using joule, and for electrical energy they are using kilowatt hour. Now in SI unit, what we have decided internationally is that heat, electrical energy, kinetic energy, what are these? These are all units of energy. So let us express all those units in terms of joule. That's why this is rational. See, advantage of SI over MKS: for heat energy you are using calorie, for electrical energy you are using kilowatt hour, and for kinetic energy you are using joule. But see, for SI unit, all form of energy will be what? Joule. Another important or advantages we have is that it's a metric system. It's a metric system. What is the meaning of metric system? It's very easy. Suppose if you are measuring a distance, what you say? Meter, that's the standard unit. But if you have to measure a larger quantity of length, what we go for? Kilometer. So just see, we are multiplying meter with 10 to the power 3 to get kilometer. I'm explaining this one. Suppose 1 kilometer is equals to what? 10 to the power 3 meter, right? Suppose there is 1 megawatt, that means what? 10 to the power 6 watt. Got it? See here, very easily from the watt you can multiply anything in terms of 10 to the power something to get a bigger unit, right? We all say 2.2 gigahertz processor, right? What is the meaning of gigahertz processor? Hertz is the SI unit, right? And when you are going for a bigger unit, what you are saying? 2.2 gigahertz. That means what? Giga means what? 10 to the power 9 hertz. See, the calculation is very easy, right? 10 to the power 9. So it's all in terms of 10. That's why we say it's a metric system. Another important part, another very important usage is that it's a coherent system. It's a coherent system of units. Let me explain you what is coherent system of units. Suppose here mass into velocity we are doing, right? To get momentum. Now you tell me, in SI unit, what will be the mass? Kg. What will be the velocity? Meter per second. Absolutely. So momentum will be kg meter per second. Now, if you want to find out SI unit, like if you want to find out any quantity, mass into velocity, and at that time, do you need to multiply any numerical value apart from that? Suppose mass is 5 kg and velocity is 10 meter per second. Let me just explain you here. Just see, momentum I'm writing in SI unit. In SI unit, what I'm saying? 5 kg into 2 meter per second. 5 kg into 2 meter per second, right? So 5 kg is what? Mass. 2 meter per second is what? Velocity. What will be your momentum? 10 meter per second. This will be your momentum. So in order to calculate this momentum, apart from 5 and 2, do you require any other values to multiply or divide? No. It's just simple as that. Whatever be the quantity mass into velocity, you just use the same values and you find out. That's why it's a coherent system of unit. Got it? So this is why we are using SI unit. Next we are going to understand dimensions. See. So coming to the dimensional analysis, let us see. So dimensional analysis, what is it saying? All derived physical quantities can be expressed in terms of some combination of 7 fundamental physical quantities. These fundamental physical quantities are known as the 7 dimensions of the world, which we are denoting in square brackets. So at the beginning of this video, I told you what are physical quantities and what are the fundamental physical quantities, and with the help of these fundamental physical quantities we can derive any other physical quantity. So that is why they are becoming the 7 dimensions of the world. With the help of these fundamental physical quantities we can derive any other physical quantity. Now just check what we are denoting these dimensions of these physical quantities. So dimension of length, how we are going to denote? In square bracket capital L. Dimension of mass in square bracket capital M. Dimension of electric current in square bracket capital A. Temperature in square bracket K. K stands for Kelvin. Luminous intensity, that's CD, that stands for candela. Time, that stands for T. And number of substance, that is mole, right? Now why we are doing this? Because there are reasons. There are some useful advantages of dimensional analysis we are going to learn. Now first let us understand how to find out dimension of different physical quantities. For example, if you ask me, sir, what is the dimension of velocity? I will say you, what is the formula of velocity? You tell me. Formula of velocity is what? Displacement by time. Displacement by time. So what is displacement? Length. What is time? T. So we are going to measure displacement, length. Displacement is what? Measurement of physical quantity, length, and time is what? T. So what will be dimension of velocity? L t to the power minus 1. Very easy. If you are asking me, sir, what is acceleration? What is acceleration? Acceleration will be what? Velocity by time. What is the dimension of velocity? Just now we have found out. What is it? L t to the power minus 1 whole divided by time. How much we are getting? L t to the power minus 2. Why minus 2 when this t is going up? I hope you all know the laws of indices. Next, what we have, if I am talking about momentum. Momentum, what will be momentum? Mass into velocity. What is mass? Dimension of mass, m. What is velocity? L t to the power minus 1. That is equals to m L t to the power minus 1. Got it? Now, if I am saying kinetic energy, what is kinetic energy? Kinetic energy is what? Half mass into velocity square. That is kinetic energy formula. Now, some of the students might ask, sir, then I have to use this half. Now tell me, what is half? What is half? Does half is having any meaning? If I say give me half, what? If I say give me half of your property, that makes sense, right? If I say half of the bread, that makes sense. If I say half of your copy, that makes sense. Half of something we have to say, right? So only half doesn't have any meaning, right? So half is not having any dimension. Why? Because half is not a physical quantity, it's just a number. So when you are using here, you are directly use mass m and what is velocity? L t to the power minus 1, that square. So when you are doing it, how much you are getting? M L square t to the power minus 2. This is the dimension of kinetic energy. This is the dimension of kinetic energy. Is that clear? Now, it's your homework. You have to find out dimension of power. You have to find out dimension of work. You have to find out dimension of, let me say, very easy. Achha, I'm just showing you this one. Force. This is a bonus. What is force? Mass into acceleration. Acceleration. What is mass? What is mass? Mass is m. Acceleration L t to the power minus 2. This will be what? M L t to the power minus 2. Got it? This is dimension of force. So these two are your homework. Okay. Now what do you think? Only these physical quantities are out there? No. There are a lot of physical quantities. You can see on the screen. Can you see? There are a lot of physical quantities. I will ask you to take a screenshot from here, or if you want, you can contact me for the notes. I'm going to give you that. So there you are going to find all of the physical quantities, and what's your job? You have to understand how you can find out the physical quantities dimensions, and you have to learn these physical quantities that I have written over here. You have to learn it. This is very important. Very, very important. Okay? Is that clear? Please take a look, and if you need, you can take a screenshot from here.